Hello guys, my name is Ali and I'm your video instructor in the dynamics course, and my goal is to present a summary of the materials that you have already had in the lectures to make it a little bit easier for you. So this is our first video, and in this video I'm going to discuss some of the terms that you need in this course. And these terms are position, velocity, and acceleration. And I have some notes here before starting. So let's see what is the mechanics first of all. So the mechanics is the study of body or bodies moved due to forces acting on them. And the mechanics can be categorized in two different categories, statics and dynamics. Statics is another course that you will have, or you're having right now. I don't know. It's about the body or bodies which are in equilibrium, and they are not moving, for example, but there are forces acting on them. But in the dynamics course, we are dealing with the bodies which are moving around, and what we want from them, we can again categorize that in two different categories. We call it kinematics and kinetics. Kinematics is about the geometry aspect of the motion, which means that where is the body, what's the velocity, and some similar stuff. And the kinetics would be the forces causing the motion. And we will discuss all of these terms during this course. And before starting to describe the terms that I want to describe, let's say something first. So, this is the basic equation in this course that we are going to deal with, which tells us that the summation of the forces acting on a body is equal to the mass of the body times the acceleration of the body that I'm going to introduce to you. And so this is the basic of everything that we're going to discuss in this course. So let's just start talking about those terms. So the first term is position. So what is the position? The position of a particle is, as you can see here, I have a graph here that's showing a particle that I'm calling that P with that symbol. And the location of this particle, I'm showing that with R, the position vector. We call it the position vector, and it's a vector. So it's telling us that it has a value and also a direction. The value of that, I'm calling that S. So R and S will be the position vector and basically the magnitude of the position vector. So, what is the second term that we're going to discuss? The second term is displacement. What is displacement? The name is already telling us what it is actually. So let's assume that we had the particle at location R1, then it moved to location R2, as you can see here. So the displacement would be delta R, as I'm writing down here. And as I said before, delta R would be the displacement, which is R2 minus R1, as you can see here. But the magnitude of the first location of the particle is S1, and the magnitude of the second location of the particle is S2. So the magnitude of the displacement would be S2 minus S1. This is the magnitude of the displacement. Again, the displacement is a vector, so it has direction and magnitude. So delta S would be only the magnitude of that. And let's move on to the third term that we're going to discuss. Let's keep this graph here. Let's talk about the velocity. Velocity is the rate of change of particle motion. So how we can write it mathematically? We write it like this. The average velocity is the displacement over the delta t, basically telling us, for example, if the particle moved from location A here to location 2 or B here, so the displacement was delta R, and the amount of time that it took to get there was delta t, so the rate will be delta R over delta t, and we call that average velocity. Again, velocity is a vector, so it has both direction and the magnitude, how we can write the magnitude, like that, using the magnitude of the displacement over delta t. So the other things that we may want to know is the instantaneous velocity, like this, which basically tells us in a very short amount of displacement that we are calling that delta r, over the very short period of time that small displacement happened, which we call it delta t, so it gives us the instantaneous velocity. So let's move on to the next term that we want to define here. The acceleration is the fourth term that we're going to discuss. What is the acceleration? The acceleration now is the rate of change of the velocity, which we write it like this. A, or the acceleration, is equal to the change of the velocity over time. And we can also write it in a different way because we already know what is v. So v is dr over dt. So we are going to write it differently, d over dt, and in parentheses dr over dt, which means that it's going to be second derivative of the location of the particle. So second derivative of the location of the particle is acceleration, and it's also the rate of change of the velocity. And you can see here that we had a particle that the velocity was v1, and then it moved and the velocity became v2. So now we are going to have a little bit of math here. Let's write an equation here. We know that a is equal to dv over dt, and here I'm just writing the magnitude. I'm not putting any arrow on top of a or v because I'm just talking about the value of a, the magnitude of the acceleration, the magnitude of the velocity. So the velocity, the magnitude of velocity, was equal to ds, the displacement, over delta t. So I'm rearranging that, and delta t or dt is equal to ds over v. Now using these two equations, basically this one and this one, I'm going to conclude another equation. So I just replaced delta t by what I had here, and I replaced it here. So then I write the equation like this, which tells me a, or the magnitude of the acceleration, is equal to v delta v over delta s. So now that I have this equation here, if and if, as I'm writing here, a, or the acceleration, is constant, then I can integrate that equation, and it will be something like this. The integral of a ds from s0 to s equals v dv from v0 to v, and it gives me this final equation that can be useful sometimes for you guys to solve some problems. And yeah, I guess I'm going to finish this video here, and thank you for bearing with me and bearing with my handwriting. And I guess it's also a good practice because you're going to see these types of handwriting a lot since you have just started. And I wish you the best. See you next time.